Next, we'll calculate the vapor pressure of a solution containing a non-electrolyte and non-volatile solute. Calculate the vapor pressure at 25 degrees C of a solution containing 99.5 grams of sucrose and 300 milliliters of water. The vapor pressure of pure water at 25 degrees C is 23.8 torr. Assume the density of water is 1 gram per milliliter. So we're given the 99.5 grams of sucrose, 300 milliliters of water, the vapor pressure of pure water at this temperature, which we could have looked up in a chart, and the density of the water. So what we need to know here is the vapor pressure of the water is equal to the mole fraction of water times the vapor pressure of pure water. And the mole fraction is equal to the mole fraction of the moles of the water over the total moles. So the mole fraction is equal to moles of water over total moles. Okay? So what we need to do is calculate the moles of water and the total moles to calculate the mole fraction, and then we just take the mole fraction and multiply times the vapor pressure of pure water. Alright, so we can take the grams of sucrose and convert that to moles of sucrose. We can take the milliliters of water which we were given and convert that to grams of water through the density, and then grams to moles through the molecular weight. Then we'll have the moles of sucrose and moles of water. From that we can calculate the mole fraction of the water and then the vapor pressure of the solution. So to work this problem, we start with 99.5 grams of sucrose, which has a molecular weight of 342 grams per mole. So we get 0.2907 moles of sucrose. We have 300 milliliters of water. We use the density to convert that to grams, and then the molecular weight to convert that to moles. That gives us 16.65 moles of water. The mole fraction of water is the moles of water divided by the total moles. So we put the moles of water here, and we add the moles of the sucrose plus the water for the denominator. That's the total moles. And that gives us 16.65 divided by 0.2907 plus 16.65. That gives us 0.9828 for the mole fraction of water. So now we can calculate the vapor pressure of the solution, which should only be slightly lower because the mole fraction of water is pretty high, about 98%. So we get 0.9828 times 23.8 torr. That gives us 23.4 torr. Next we'll work 4 more practice 14.6. Calculate the vapor pressure at 25 degrees C of a solution containing 55.3 grams of ethylene glycol and 285.2 grams of water. The vapor pressure of pure water at 25 degrees C is 23.8 torr. First we'll convert grams of ethylene glycol to moles of ethylene glycol, then grams of water to moles of water, and then we'll calculate the mole fraction of water as we did previously, and finally the vapor pressure of the water. Alright? Or of the solution. So let's go ahead and get started. The moles of ethylene glycol is equal to 55.3 grams, and that is 62.07 grams per mole. Alright, and that gives us 0.890926 moles for the ethylene glycol. Now our moles of water is equal to to 85.2 grams of water. Alright, and 1 mole of water is 18.02 grams from the molecular weight. So that's 15.82686 moles of water. Alright, so now the mole fraction for the water is equal to the moles of water divided by the moles total, which is equal to 15.82686 divided by 0.890926 plus 15.82686. So that's equal to 0.946777. And so that leads us to the vapor pressure of the solution being, which is due to the water, is equal to the mole fraction of the water times the vapor pressure of pure water. So that's equal to 0.9467077 times 23.8 torr. And so that's equal to 22.5 torr. For more practice 14.6 says, a solution containing ethylene glycol in water has a vapor pressure of 7.88 torr at 10 degrees C. Pure water has a vapor pressure of 9.21 torr at 10 degrees C. What is the mole fraction of ethylene glycol in the solution? So remember, the total of all mole fractions has to equal to 1. And the vapor pressure of water is equal to the mole fraction of water times the vapor pressure of pure water. Okay, so the mole fraction for the water is equal to the vapor pressure for the water from the solution divided by the vapor pressure for pure water. Okay, and that's equal to 7.88 torr divided by 9.21 torr, and that is equal to 0.8555917. So basically we're saying this solution is 85.55917% water. So the rest of it had to have been due to the ethylene glycol. So the mole fraction for the ethylene glycol is equal to 1 minus the mole fraction for the water, which is equal to 1 minus 0.8555917. Alright, and so that's equal to 0.144.